Okay, this is a review for quiz 3 on Khan Academy. I pulled some of the questions as examples to review over, also another way to just explain how to handle the different types of problems. So this first one, we're just asked to find G of 3. They gave us our first term of the sequence is 4, and they're giving us our function here. We can see that it's adding 3.2, so this is arithmetic, and we are going to take and work our information backwards. So we have to know G of 2 to get to G of 3. So if we first find, first G of 1 is 4, that's given here. Then G of 2 can be found by using this formula. So we would take 2 is n minus 1 and add 3.2. And I'm just going to show this step by step. So this would give you G of 1 plus 3.2. G of 1 is 4, so we mark that out. Add 3.2. And so we know that G of 2 is 7.2. Okay, and then we're going to take that information and find G of 3. So what we're going to do is plug it into our formula up here. 3 minus 1 is inside the parentheses. We're still adding 3.2 because that's our common difference. 3 minus 1 is 2, so we're really using the second term, adding 3.2 to that. And so 7.2 plus 3.2 is 10.4. And I believe this was one of those that was in the review video. All right, and another problem like that. So they gave us the first term is 4, the second term is 25, and this is our function. So we need to take f of n minus 2 multiplied by f of n minus 1. They're asking us for the third term. So we are gonna start off, n is 3 minus 2 times f of 3 minus 1. And so this is going to be f of 1 times f of 2. So the first term times the second term. So we're going to take these two. Term 1 is 4 times term 2 here is 25. 4 times 25 is 100. So f of 3 is 100. So that answers our question. For this next function, same thing. You might want to pause it and see if you can find the second term yourself. Our first term is defined as negative 12. We can see that this is going to be some type of geometric because we're multiplying. So we have h of n minus 1. We're going to take our term 2. I already put 2 in. H of 2 minus 1 times 2. So this is going to be h of 1 times 2, and the first term was defined as negative 12, so that's where I'm getting that from, times 2, which is negative 24. So the second term of the sequence is negative 24. Okay. Our next type of problem is being able to determine what domain it needs to come from, or what it needs to be set as. So consider the geometric sequence first, 4, 8, 16, 32. Looks like we are doubling each time, so times 2, times 2, times 2. If n is an integer, which of these functions generate the sequence? Okay, so there's just multiple choice. You're going to want to verify to make sure that for a domain, so if n is greater than or equal to 0, if you put 0 in for n, you should get this first term. So this would be 4 times 2 to the 0 power. We know that anything to a 0 exponent is 1, so that's 4 times 1, which is 4. That is our first term, so that's a good sign. Let's try one more. So let's say we put 1 in place to make sure it's increasing the right amount. 2 to the first. So that is just 4 times 2, which is 8, and that's exactly what we want here. So far, this is one of our answers, and we want to continue to check the others because it said select all that apply. So let's see, b of n, 2 times 2, so there's our common difference, raised to the nth power, and it says that n is greater than or equal to 1. So for our first term, it should be 4. If we put 1 in for that, do we get that? So 2 times 2 to the first, and that's just 2 times 2, which is 4, so that checks out. Let's go the next step up. So what if n is 2? So 2 times 2 to the second, 2 to the second is 4, and 2 times 4 is 8. So that checks out also, so it's going to continue to increase that way. So B is another answer. Then we get down to C and D. Notice that it does not have 2 written in here, but we're still going to check it. So if n is greater than or equal to 2 starting out, so if we put 2 in, we should get 4 for our first term here. So 4 to the second minus first, which is just 4 to the first, which is 4. Let's try one more. Oh, wait. Yeah, that's right. So then 4 to the third, that should give us 8, because after 2 is 3, so 4 then 8, minus 1, and 4 squared is 16. So it actually skipped the term 8, so this is not an answer. And then we move on down to the next one. What if we put 3 in for it? So 4 to the third minus 2 is just 4 to the first. That checks out. But 4 to the fourth minus 2, we're just increasing from 3 up because it says it has to be greater or equal to. And so 4 to the second is also 16. So that is not our next term. D is no longer an answer. So we should have selected A and B on this one. Number 5, David is writing explicit function for the arithmetic sequence, 10, 13, 16, 19. They told us it was arithmetic. We can see that we're adding 3 each time for our common difference. He comes up with S of n equals 7 plus 3n, so there's our 3 there. What domain should David use for S so it generates the sequence? Okay, then we have 4 choices, where n is greater than or equal to 0, where n is an integer. And this one's the same thing, except for it says it's any number. Well, we know it can't be any number because sequences are not going to have decimal terms. So we can get rid of that one. Where n is an integer, if it's n is greater than or equal to 1, that's possible. N is greater than or equal to 1. N is any integer. We don't have term numbers that are decimal or fraction amounts, so we're not going to go with D. So from here, if I put 0 in place of the n here, will it give me this? And then build off of that. So 7 plus 3 times 0, well, that's 7 plus 0, which is 7. Our first term is 10, so this is not an answer. That leaves us with C as the answer, and let's see why. If we put 1 in for n, so 7 plus 3 times 1, that's 7 plus 3, which is 10, so that checks off, and we want to always go one more term at least. So 7 plus 3 times 2, that's 7 plus 6, and that is 13, so we know that that works.